Hello everyone, my name is Vladi. Today we'll talk about why and how top-performing apps like Figma and Notion have leveraged the power of real-time collaboration and give you a quick overview of how you can also make your Node.js apps collaborative very quickly and with a lean and open-source tech stack. When I think of modern applications, I have certain expectations in mind. More specifically, in the formula for creating a modern application, I would expect to add certain ingredients. For example, the application would need to be instantly available anywhere in the world, accessible via web browser or your mobile device, optimized for user experience, making it effortless to perform the task you want to complete, and for those of us who work in distributed teams, whether because of geographic distribution, preferred working style, or because of the size of your organization, you may also expect to see other functionalities. The ability to share your work with your team, the ability to get direct feedback without switching to another app, and the ability to collaborate on the same project. It's surprising that not all of these expectations are being met by modern applications today, especially when it comes to collaboration. And especially knowing that the capabilities are out there, and they have been an integral part, for example, of the gaming industry for several years. Before I continue, a quick introduction. I'm the community director for multiplayer. My background is in community building and customer service in the tech space. And I was fortunate to work for other user-centric companies like Prisma and MongoDB in my previous roles. I hope I don't disappoint too many of you when I say that multiplayer is not an MMORPG, a massively multiplayer online role-playing game. Multiplayer is a collaborative SaaS platform that aims to support teams working on large-scale or complex distributed systems, with numerous components, interactions, and dependencies to effortlessly align within their team and with other stakeholders, PMs, Ops, QA, on how to visualize, design, and manage those systems. This need for effortless alignment, real-time visual collaboration is so important to us that it even inspired our name. And it led us to spend a lot of time researching, investigating, and trying out how to build collaborative features in our app using a lean and OSS-focused tech stack. Today, I wanted to share our experience and learnings in adding real-time collaborative features and maybe spark some ideas on how you can also add these features to your own apps. Real-time collaboration is now table stakes, and that's also due to the benefits it brings to the user experience. Think back of how teams used to work. Everyone worked individually on the same project, but in silos. And then they would exchange that project file back and forth with their individual additions and changes, and somebody would have the dubious pleasure of reconciling, if at all possible, the work of the entire team and producing the final version of the document. Now, compare that to the experience of working together in a single shared space, side by side, virtually, using a common language and framework. You can align, communicate, and drive consensus effortlessly. And it's not a coincidence that Figma, Miro, Canva, Notion, etc. have been so popular and successful in the past few years. And beyond them, many SaaS businesses, even companies that haven't traditionally thought of themselves as collaboration first, have embraced this trend. In fact, besides empowering effortless team collaboration, another big benefit of collaborative products is that they are virality machines for businesses. The ability to invite and involve more stakeholders in a project ensures, 1, that more users use your product, and 2, a higher adoption and retention rate. Because when distributed teams are able to achieve more together, your software becomes a key part of how they work. So, let's start by pinning down a bit better what we mean when we say real-time collaborative tech. There have been many attempts to coin a term to describe this trend, including multiplayer collaboration with a lowercase m, deep collaboration, and collaborative enterprise. We consider an application to be real-time collaborative when it has these 4 functionalities. The first one is real-time updates. A change made by one user must propagate to all other users instantly, or as near as instant as the internet allows. Live playback. Each user should be able to watch in real time precisely what their collaborators see on their side, right down to watching each person's cursor move about their screen. Presence and status. So have an easy way to see who is online and available to work. And the final one is data integrity. With data and changes coming in from multiple people at once, there is a risk of conflicts, and preventing data loss from conflicts is both a UX and a backend challenge, as we'll see in this presentation. Now that we have aligned on the definition, let's talk about how you would go about concretely building a real-time collaborative product. So the first approach that might come to mind is to extend an existing RESTful API and simply broadcast request and response messages to all connected clients using the WebSockets. This works fine for changes that don't conflict, for example, both clients agree on the logo design. But it leads to bad things when multiple clients try to change the same thing at the same time. For example, they want to propose different logo designs. As another example, imagine typing in a document, but the words show up out of order or individual characters are in odd places. That's because more than one person is typing in the same place on the document at the same time, but you don't have good conflict resolution strategies. And indeed, handling concurrent editing in a multi-user environment gracefully is very challenging. In order to merge conflicting changes in a way that makes sense to the end users, you have to share not just the value of the change, but the context of the data and the state of the client making the change. Luckily, there are some great technologies that come to the rescue. The first one is operational transformations, OTs. The second one, conflict-free replicated data types, crdts, among others. Operational transformations are an algorithm for the transformation of operations such that they can be applied to documents whose state have diverged, bringing them both back to the same state. And conflict-free replicated data types, as the name suggests, provide several data types for handling changes and resolving conflicts from multiple clients operating the same data at the same time. And to be clear, you could still use WebSockets, but it's just a lot more work and time. Also, depending on your problem space and the desired behavior for different states, you may find that you'll need a custom approach inspired by these two traditional methods. For example, if you're a startup and value the ability to ship features quickly, OTs, the technology used for Google Docs, might be too complex. Likewise, you might get inspired by multiple separate crdts and use them to create the final data structure that best represents your document, similar to the approach that Figma took. Today, we will focus on the technology that we use at Multiplayer and that we feel offers the simplest, fastest, and most powerful approach to implementing collaborative features, crdts. There are two approaches to crdts: operation-based crdts or commutative replicated data types, and state-based crdts, convergent replicated data types. Both can provide strong eventual consistency, and this means that even if clients drift because of short-term connection issues or suffer from high latency, the data on all connected clients will eventually resolve to the same final state. crdts are really a collection of simple algorithms such as last write win registers, grow-only counters, positive-negative counters, grow-only sets, two-phase sets, sequence crdts, among others. We chose a popular OSS CRDT implementation called y.js. It provides data structures like docs, maps, and arrays that map easily to regular JavaScript data types. So when we designed our app, we didn't need to radically refactor things to use y.js. There are also other benefits to y.js. It has a huge number of ready open source integrations, code editors, whiteboard apps, rich text editors. Any data structure can be supported with y.js shared types. It allows also for painless client to reconnect without losing client progress. It's network agnostic, very easy to use awareness features out of the box, and it also has a very big community. One thing to keep in mind is that using crdts and y.js isn't just about data types. You also need to think about your system architecture. It's possible to use crdts in a peer-to-peer orientation. However, because we provide features like snapshotting, we decided to incorporate a central peer in our system to resolve conflicts and to provide a definitive source of truth for our data. Using the example from the hard way, let's say that both clients are working on the same logo. Each one makes specific changes. For example, one client changes the color of one square, while the other client changes the color of the other squares and their order. Those changes will be propagated to the central peer, who is using y.js library, and would resolve any conflicts, so that there is no drift between the states. And in other words, everyone is looking at the same version of the logo. While this solution is simpler to support, it does have a few drawbacks that I want to mention. So for example, the first one is that it can be more CPU and memory intensive, since you need to server-side resources when editing documents. The second one is that scaling is more complex because you need to be able to run the central peer close to the clients. But overall, this is a much simpler approach because you end up needing some central services anyway for document storage and management. So let's do a quick recap. This is an overview of the multiplayer system architecture as visualized using the multiplayer UI. And we have opted to have our crdts peer sessions managed by a central peer, the collaboration service. This service has three main functions. The first one is serving the latest version of the document when a new client connects. The second one is sharing edits across all connected clients. And the third one is saving snapshots of the document. We keep latency low by deploying collaboration services close to our users, so latency is minimized. And we have a directory service cluster to make decisions about where to place collaboration sessions, track existing sessions, and even move sessions. Now that we've seen how we implemented real-time collaboration features, let's look at the specific features. And before I go on, I wanted to make a quick aside. We didn't implement all of the possible real-time collaboration features, but only those that make sense for multiplayer. Also, we didn't always use y.js. We only used it when it made sense. So this approach makes sense when we require conflict resolution between changes from different users or for temporary things that belong to the document. Think, for example, user info or cursors. There are three different categories of real-time collaboration features. The first one is awareness or presence, features which allow you to automatically track and communicate the online status of your users. So for example, avatar stacks. Now note that since we have a central peer and since y.js is network agnostic, we decided to use WebSockets to display this. Also because we're pulling this information across multiple documents at the project level. However, it can be also achieved with y.js. Other features that fall into this category are live cursors and user in application, which you would use a similar logic in y.js to implement, and typing indicators, which is a feature we haven't implemented yet, but will likely do in the future. Another category of collaborative features is state synchronization. Features include all those user actions and changes that have to be synced correctly and at low latency, so live updates is an example. Then you have co-editing, undo and redo. And an easy way to see the y.js implementation of this category of features in multiplayer is to think back of the multiplayer system architecture that I showed you a few slides back. One client is moving the collaboration service to a different location in the system architecture, while at the same time, another client is renaming that same component, the collaboration service, something else. And both changes would be combined together without issues in a final state. The last and third category of collaboration features is the pub/sub messaging features, which are needed to deliver the right message to the right client in real time. This comprises comments and push notifications. We use y.js, as I mentioned, only for things that require conflict resolution between changes from different users or for temporary things that belong to the document. And so, comments do not require simultaneous edits because comments can have only a single owner and they're not temporary. And for this reason, we didn't use y.js to implement this feature. Instead, we used the REST API call and WebSocket notifications. And although we haven't implemented yet push notifications, we would be using WebSockets for those too, although you can use y.js for state synchronization. Now, while using y.js was surprisingly easy, there were some challenges. The first being learning was how to keep track of order. Arrays are supported in y.js, but order of elements is not maintained without a little work. The first approach you might think of is to add an integer for the order. However, the drawback is that whenever a new element is inserted, you have to change the order value of every single element that follows it. This is not a scalable solution, especially if you have a very long list. What we ended up using is fractional indexing, which is also the approach that used by Figma. This solution has the benefit of inserting an element without having to update all of the elements that follow it. To implement fractional indexing, it's best to use an arbitrary precision library rather than the built-in JavaScript number type, which is a 32-bit floating point number, because it has limited precision. There is a limit to how many times you can insert something into a list before you hit the precision wall of the type. And instead, with an arbitrary precision library, you don't run into this problem. Our second learning, to which I alluded to already when discussing our system architecture, is that while y.js supports a peer-to-peer design, where you don't need to have a central service, that may not fit your business model. In fact, for us, having a central collaboration service was very much necessary to be able to implement features like snapshotting and storing data in specific locations because of security requirements, think GDPR. However, a peer-to-peer architecture would be better suited if your application has a requirement, for example, to operate in an offline mode. Our third learning was about defining the scope of collaboration. More specifically, being selective on where and how we use real-time collaborative features, because they might be unnecessary or worse, confusing. So let me give you a little bit of context. Multiplayer supports branches, chain sets, and views of the platform architecture and API. These represent either copies of original documents or filtered views of the content of a document. And when deciding how to show the awareness features, so think back avatar stack and user cursors, we decided to only show the users who are viewing the same document in the same branch at the same time, as you can see in these two branches, instead of showing all of the users who are working on the same platform architecture across all branches, because that would be unnecessary and confusing. The last learning I'm keen to share is that y.js can lift a lot of the overhead of implementing collaborative features, but it doesn't do everything for you. For example, it doesn't support cross-document changes where you need to propagate information from one place to another. To give you another concrete example, in multiplayer we have several documents that have dependencies. For example, the individual component of a system architecture may be referenced in different places: component list, component description, platform architecture. To be able to ensure that any change to an independent document would flow up to other documents that reference them, we needed to wire up dependencies between different data structures in our app, listening for changes in the y.js document. So, for example, if you change the name of a component in the components view, that change will flow to any other platform document that shows that component automatically without needing to refresh. And this is all to say that you may find that your app requires some UX choices like that, which are not supported by y.js. So, to recap, why should you build for collaboration within your app? With real-time collaboration, you ensure a better user experience. In other words, quicker time to fun. Your users can align, communicate, and drive consensus effortlessly. Shorter production cycles, quicker time to market, Making sure that your users are aligned on the expectations, responsibilities, requirements, roadmap ensures that there is no miscommunication or backtracking. Therefore, they can work more productively and deliver results faster. Also, they are working and communicating in a shared space, which means less context switching and wasted time. And this is not to say that real-time collaboration alone is the ultimate productivity booster. However, it is an expected enhancer of the user experience. Also, increased business revenue. Because your tool is adopted by entire teams, if not entire organizations, it becomes a key part of the company's workflows, giving you higher retention rates. So, the final advice we can give you is to not reinvent the wheel. There are lots of solutions for adding real-time collaboration to your app, and while we decided to use y.js and build in-house these functionalities, we can also recommend using a SaaS provider like LiveBlocks, but there are so many others out there as well. So for example, Apply, PlayKit, CollabKit. Our second advice is to embrace collaboration from the start, if you can. Adding real-time collaboration features as an afterthought to an existing product or to only part of an existing product is more messy and difficult. It's not impossible though. You can certainly introduce y.js in an existing system and it would take a lot less work and time than doing the same with WebSockets. However, by including it in your early designs, you ensure that the full UX experience is collaborative and your technology choices will easily support the evolution of these features. Thank you for listening to my talk, and I hope you got inspired to add real-time collaboration to your apps. If you'd like to try yourself the features we built into multiplayer, we'll be launching our open beta very soon, and we'd love your feedback. You can find me on X, LinkedIn, or around the Discord server if you have any questions.